Welcome to the Chemistry Made Easy channel. I am Dr. Ashok Muri. Today we are going to discuss the remaining part of the distribution of elements on the earth. So in this part we will see the solubilities of minerals. Now if we see the solubilities are mainly concerned with respect to water, because at the time of formation of universe or at the time of formation of our planet the earth, the conditions were different, not like today. Therefore at that types of conditions the minerals which were coming into existence on the earth have the specific solubilities. For example, there was only the important solvent, universal solvent, we say it is water. So during the formation of earth, the water was in large amount, and therefore it has made long time effect on the solubilities of minerals which were formed on the planet our earth. So water bodies where the place where the minerals can be found to be soluble or not. So the solubilities of mineral in water depends upon the elements and their oxidation states. So every element is not equally soluble in water. Their oxidation states are also responsible to maintain or cause the solubility, because the solubility varies with oxidation states. So that can be discussed in detail in forthcoming lectures. Now the elements were roughly divided on the basis of their ease of reduction and combination with oxygen and sulfur. Means we are dividing the elements at that time on the basis of their reducing ability, means how easily they can be reduced from their oxidized states to the elemental states, and their combinations with oxygen and sulfur. Next is siderophiles. Siderophiles means this portion will help us to understand which elements are present in which specific location on the earth and inside the earth. So we have last time discussed the cross section of the earth, and in that section we have found that the earth is composed of various layers in which the elements and their compounds are deposited. So of that only we will see here some siderophiles. So siderophiles are iron loving elements, means which are in very close collaboration or in very close association with the iron. So concentrated, these elements are concentrated in core. Last time we have seen the core part of that earth's crust. So that portion will contain the iron group of elements we see. Iron, cobalt, nickel, copper, technetium, ruthenium, rhodium, that is palladium, silver, molybdenum, tungsten, rhenium, osmium, iridium, platinum, gold, that is AuP, phosphorus, arsenic, antimony, bismuth, sulfur, selenium, tellurium, gallium, germanium, and tin. So these are elements called siderophiles, which are existing in the metallic core. Then next type of elements is lithophiles. These are rock-loving elements. So they are present in combination, or they combine primarily with oxygen and halides. Means these elements are found in that portion, that is the rock loving elements are found in the form of their oxides and halides. Such as, so these elements are more abundant in the Earth's crust. So they are present as lithium, sodium, potassium, radium, cesium, francium, beryllium, magnesium, calcium, strontium, gallium, radium, scandium, yttrium, lanthanum. So lanthanum includes the complete series or group of 14 elements coming after lanthanum. Actinide series, which are the group of elements coming after or following the actinium. Then titanium, zirconium, hafnium, vanadium, niobium, tantalum, chromium, manganese, boron, carbon, aluminium, silicon, halides, antimony, like polonium, antimony, this is astatine, polonium, bismuth, radon, and zinc. So these elements are forming their oxides and halides. For example, if we say lithium or sodium, potassium, these are mainly existing in the form of their halides, which are stable in the nature. So, as a result of this, the other elements which are present are also either in the form of the halides or their oxides. Next type of elements or group of elements found in the earth is chalcophiles. So this word arises from Greek word that is chalcos, which means copper. It combines more readily with, so this group of elements combines, or copper combines more readily with sulfur, selenium, and arsenic, and that is why they are called chalcophiles. These are found in the crust. What are these elements? These are molybdenum, silver, cadmium, indium, mercury, tellurium, thallium, sulfur, arsenic, antimony, antimony, tellurium, and bismuth. So these elements are in the form of their sulfides, selenides, arsenides, etc. Then next type of group of elements which are existing on the earth are called atomophiles. These are called atomophiles because they are present in the gaseous state. For example, hydrogen, nitrogen, oxygen, helium, neon, argon, krypton, xenon. So these helium to xenon are noble gases, while these are hydrogen, nitrogen, oxygen, which are most important elements on the earth. So these divisions like siderophiles, lithophiles, chalcophiles, and atomophiles, these divisions can also be observed on the or in the periodic table. So we will discuss it in forthcoming lectures when we will discuss the elements or periodic table. Then leaching of aluminosilicate, we can take the example of this aluminosilicate in order to understand what is meant by leaching process. So when the elements were existing or coming into existence on the earth, they were leached, means dissolved in water and carried to some other place, and there the water is evaporated and the minerals are deposited in that place. So we can explain this in the form of this reaction, that is KAlSiO3 Si3O8 4KAlSi3O8. This is S for solid. So it is aluminosilicate. It combines at the time of formation of the earth. It combines with 4 carbon dioxide, 22 water, and gives us the ionic form of K plus. Bicarbonate ions, that is HCO3 minus, and AlSr4O10 OH8. This is also in solid state which gets deposited after evaporation of water present in it. Here Al4SiO4O10 OH8 contains the aluminium in very large quantity. That is, higher concentration of aluminium is found here on the earth in this form. So this 8H4SiO4 is in the aqueous state, means in the dissolved state. It is a silicate and it is leached away, means this portion of that silicate formed is dissolved, means gets dissolved in water, and it gets carried away to some other place where it is deposited. So this is called leached away, means dissolved and taken away to some other place, that is leaching. So leaching of soluble silicates, for example, also bauxites are observed at places with heavy rains in the past, that at the time of formation of the earth. Similarly, other such elements are also leached away and deposited in different places on the surface of the earth. Solubilities of minerals are best explained by modern concept of acid-base theory. So this portion can be explained in the acid-base theories, where we will discuss this modern concept, that is HSAB concept. So this concept will explain very clearly, very promptly, and how the minerals are coming into existence on the earth of a specific type. Means we cannot expect the minerals of, for example, the lithium in the form of their oxide. We cannot expect oxides of sodium, potassium, so these elements, because these are unstable in that atmosphere where we can also observe at present also. So oxides of such alkali metals, some alkaline earth metals, are not stable in the existing atmosphere. Similarly, we cannot expect the oxides of some other elements or metals. Now we can take simple example of formation of water. Water contains hydrogen and oxygen. So the presence of oxygen and hydrogen together, it gives more stable compound, that is water. But instead of this, if we consider, means if we replace oxygen by sulfur, we will get H2S. If we replace oxygen from water, we will get H2S. Here, this compound is not stable. Therefore, it does not exist in the liquid state on the earth like that the water exists. So, water is more stable. Its boiling point is 100 degrees centigrade. But this H2S at conditions of room temperature exists in the gaseous state, that is unstable. Why it is so? This is because the bond between this H, hydrogen and sulfur is not equally stable like that with oxygen and hydrogen. So this can best be explained by this HSAB theory. So it will be discussed in the theories when we come across such theory in the next time or in future. Till then, goodbye. Thank you for watching this lecture. Please subscribe to this channel if necessary, and please press bell icon and like button to encourage us. Thank you very much.